Hello, this is for 1B class. This is a lesson for March 24, which is tomorrow, Tuesday. But I want to do it ahead of time, okay? So that way you guys can, if some student want to read ahead. We're going to do 7.7. We're going to learn how to approximate integral. So we have been learning how to integrate by using different technique and doing some different type of problem. But there's some type of problem we just cannot integrate by any technique we learn. So for instance, like this problem. From 0 to 3, 1 plus x to the cube power. You can see that no matter what you do, I'm going to able to integrate. U sub's not going to work. You don't have an x squared outside. If you use the set trig sub, no, it doesn't work because there's no pattern for this one. So in this case, the only way we can do is by approximate, okay? When we approximate, we have 3 different rules. The first rule is called a midpoint rule. So what we do is, let's say this is the function, the graph of a function. To integrate means to find the area under here, right? Means to find the area here. So we want to find this area. So we're going to just like Riemann sum, we're going to break this into n portion, okay? So n parts. And each part here is a delta x is equal to b subtract a divided by how many part we divide. So that's my delta x. So I'm going to take one of them out, okay, the first one here. And you can see that I'm going to use the midpoint, so the middle point of the bar. So the middle point draw up here, then I make a rectangle. So make a rectangle right here. Okay, so that's the first part. And you can see that I come out the graph a little bit, and then I shrink my, then I take, I come out the graph a little bit, then I inside the graph a little bit. So the little bit part are basically filled by the one you come out. Okay, so like the second one, this little red outside, fill the red inside. So that way they can close the gap, so that graph is a little bit more approximate like the area. So the midpoint is equal to the 2 points next to each other, add together, divide by 2. So a plus x1 divided by 2. So that's your x1 bar, okay? This is your x2 bar, okay? I didn't write it. So this is for here. Your x2 bar is equal to x1 plus x2 divided by 2. So we continue the same pattern all the way. So the area from A to B will just equal to m is the middle, okay, the midpoint rule, the first letter. N is how many parts you're going to divide. And take all the midpoint, add together, all the y value add together, times by the width. Okay, so length times the width. And then add them all together. That's the area for this part. So that's for midpoint rule. But this rule is not very good because when you fill the gap, you can see they're not exactly filling exactly the equal parts. Okay, they're a little bit smaller here, a little bigger here. So the approximation is still a little bit like not very accurate. So we're going to do the second one. Okay, the second rule is a little bit better. It's called Trapezoid rule. The Trapezoid rule is basically instead they make a rectangle here, they after divide it, okay, I only divide 3 because it's easier for me to draw. After divide, they connect the endpoint together, okay, they connect this endpoint together. So it looks like a trapezoid. So I take this one out and I rotate it 90 degrees so get to here. So this part is delta x. Once I rotate it, that's my delta x, okay. This part is my FA. And when I rotate it, that's the top part. And then this part is my fx1, and I rotate it, that's my bottom part. The trapezoid formula is like this. Trapezoid formula for this part is equal to top base, add to the bottom base, top base add to bottom base, divide by 2, then times by delta x. It's kind of like you average these 2 lengths, okay, average 2 lengths will become the length inside here, okay, and then times by this, times by the width. So that's the formula. And that's for the first one. Now for the second one, so this is my A1 here, and that's my A2. Okay, this is A1. My A2 will be fx1 plus fx2 add to 2, so that'll be right here. And then times by the width, times by delta x. So the continued pattern is the same, okay? And the formula for this one, so I have my midpoint formula right here and my trapezoid formula. I have to erase this part. And I want to show you how they get the formula from, okay? So I use the same pattern goes on. So my A, okay, my trapezoid, they use a T, okay? This is continuous number 2. The trapezoid n will equal to, okay, A1 plus A2 plus A at the end. Your A1 just equal to, I factor out these two. I factor out the delta x over 2 for each. They all have a delta x over 2, okay? And then for FA plus fx1 plus fs1 again plus fx2 and so on. And the last one should be, you can see that A2 have for fs2, the last one should be A1 have for fs1, so the last one should be fxn, okay? And then I'm going to, oh, my Sn is a B, fsb, sorry, so my B, because B is my last one. And then I combine, oh, this is fs1, sorry, this fs1. Because it's FA, FS1, FS1, FS2. And then I combine these two together, so that become FA plus a 2FX1. And guess what happened? The FS2 also the last one. The A3 will have a FS2 also. So 2FS2. And then until the last one's FB. And that's the formula for trapezoid. So we have the formula for, and then, oh, one more. Oh, we don't, oh no, that's it. I'm sorry. So this is equal to that, okay? I just didn't write the first portion up. So this is equal to FAB fx d of x. It's equal to this, okay? I just didn't write it. And then, so this is a midpoint formula. Now, midpoint formula use a middle point. Trapezoid formula, that's how you use it. So FA, 2, 2, 2, all continue, and then all the way to FB. And the last formula is for Simpson's rule. And that one's a little bit more better than trapezoid's rule. A little bit more close on the approximation. So the last one is Simpson's rule. Simpson's rule is like this, okay? If you have a, and they divide it again. So this is my A, x1, x2, and so on, all the way to B. And what they do, they take each one of them, okay? They make it like a parabola, okay? Parabola. And as my parabola is not very good here, so they try to make it closer to the to the curve, okay? So this is like a parabola, part of parabola, part of parabola, and continue like that. And so they're more closer to the actual graph, okay? And the rule, I'm not going to develop this one because it takes too long. So I'm going to just go ahead and write it. So FAB. And this rule is, so Simpson rule is SN. Okay, and that will be this time delta x divided by 3. This is divided by 2. This is divided by 3, and then we have FA. The last number will 4 fx1. Okay, and then will be 2 fx2, and again we go to 4 fs3. And continue the pattern all the way to FB. They also 4, 2, 4, and then the last number should be 4 before you go to FB, okay? So that's the 3 rule. Now we're going to do some exercise, and we're going to see which one is more accurate. The truth is these are more accurate because they're more like try to close to the graph. So let's try a problem from your homework assignment. Okay, the form is not that hard to memorize actually. Here's the problem number 10. Okay, we have from 0 to power 2 cube root 1 plus the cosine x dx. Again, this one you cannot do it by any other way. Okay, so approximation is the only way to go. So we're gonna try. They want to try Trapezoid's rule, Midpoint's rule, and Simpson's rule. So they want to try Trapezoid's rule first. They tell us that n is equal to 4 parts, so they want to divide by 4. So before we try any rule, we're going to find delta x first. So delta x equal to power 2 minus subtract 0 divided by 4. So equal pi over 8. Now delta s is the width of the rectangle, so it's always a positive. So we're going to try Trapezoid's rule. So we're going to do T4. So to do T4, we can see that by the rule, T4 will equal to delta x divided by 2. Okay, so pi over 8 divided by 2. And then FA, so F, this is your A here. Now A is equal to 0, and B is equal to power 2. Because start from 0 to power 2. So F0, okay, plus 2 Fx1. So you need to find your x1 also. So this is 0. You divide by 4 parts, so 1, 2, 1, 2, 1 more, 3, and then 4. So this is power 2. And to get Fx1, so you just add the power 8. Okay, 0 plus power 8. Add another power 8 here, so that'll be 3 power 8. Add another power 8, so it's 4 power 8. Oh, this I made a mistake on this one. Sorry. Add another power 8, I get 2 power 8. Add another power 8, I get 3 power 8. Add another power 8, then I will get 4 power 8, which is the same as power 2. Okay? You want to simplify, you can, but you don't have to because put in the calculator. So the second one will be power 8 here, plus 2 again, F 2 power 8. Okay, add another one, so that'll be 2 F 3 power 8. And then add to the last one. The last one you don't need to put 2. Okay, so 1, 2, 3, 4, 5, total 5 of them. We got 4 parts of 1, 2, 3, 4, 5. So that's 4 parts. 4 parts but 5 numbers. And it comes out approximately to, use your calculator, so keep 6 decimal place, 1.838967. Okay, so that's for T4. Part 2, we're going to learn about we're going to use the midpoint rule, so M4. So midpoint rule, we define the midpoint first. Okay, 0, 1, 2, 3, 4, 1, 2, 3, 4. 4 part 1, 2, 3, 4. Okay, so this is a power 2, power 8, sorry, power 8, 2 power 8, 3 power 8, and power 2. And you're going to get the midpoint, so you divide it first. Okay. You take the 0, 0 plus power 8 divided by 2 is equal to power 16. So this is power 16 here. And then don't divide again. You can if you want. And then you just add the power 8. So this is the 3 power over 16. Okay, add the power 8. You add power 8 means you add 2 power 16. So this is 5 power 16. And you can see there's a pattern here. 1 pi, 3 pi, 5 pi, and the next one should be 7 pi. So this is all your midpoint. And then now you can put it inside the formula. And so your M4 is just equal to delta x. This time you don't need to divide by 2, you just take the delta x, okay, power 8. And then you go F, the midpoint, so pi 16 plus F 3 power 16 plus F 5 power 16 plus the F 7 power 16. And so 1, 2, 3, 4, so 4 midpoint, okay? And then you approximate the answer. Guess what happened? You get 1.84, 1.84, 5390. So this one's a little bit bigger than this one, okay? But we know this is probably more accurate than Simpson's rule. So, then midpoint's rule. Sorry, then midpoint's rule. So, you know midpoint's rule for the least favorite one. And the last one is we go C, number C. So that would be Simpson's rule, okay? But the good news about Simpson's rule, you can just use this one, or the point here, to do, except you change the numbers. So we're gonna S4, we take pi over 8, this one divide by 3, okay, instead divide by 2, you divide by 3, divide by 3 here, and then you're gonna go F0, same point, but you have 0, 4, 2, 4, this one. So this change to 4. That keep the same. This change to 4. Oh, this is 2 pi. Sorry, 2 pi. This change to 4. 4. Okay, and these keep the same. Oh, this is 2. Power 2. Okay. So you can see that Simpson's rule, you can borrow from Trapezoid's rule, except you change this to 3, this is 4, this is 4, then that's it. And then guess what happened here? When you approximate this one, it comes like equal to 1.843245. So you can see this number here and this one is not more closer than this one. If you use the calculator, your answer will be almost like this one. Okay, you can use the calculator to integrate this one, and that's how it's gonna come out. So this is a session 7.7.